Can you all hear me? Can you hear me? Okay, sure. So my name is Alexandre, but everybody knows me as Laka, as he mentioned earlier. I'm a programmer, and I have been working for CodeMiner for about 2 years now. And music has been a hobby of mine ever since I was like 11 when I started to play guitar. But then on my teenage years, I got bitten by the electronic music bug, and with that, I switched from guitar to electronic music production. And even though I really suck at it, I never really um, got away from it and always kept interested in it and always kept researching about it. And throughout the years, I realized something that is kind of a problem with most music producers, which is that producers are really into analog gear. And this picture is an example of what the dream setup of a producer looks like. So even though the owner of the setup is really into technology, this is Deadmau5's studio. He still invests a lot in analog gear. Um, and I think you can already understand the first main problem that comes with this, and it's that this stuff is really expensive. And the second, and I think most important problem, is that since producers like analog stuff so bad, technology in music gets kind of stale and doesn't evolve as much as in other media. So meanwhile, you see technology in like games and movies getting better and better and faster, such as like you see ray tracing in games or VR and stuff like that. Meanwhile, in music, we don't get the same evolution. And this love for an analog gear comes from the desire of producers to sound unique, because analog gears usually gives a warmth and uniqueness to the sound that many people like to pursue in order to feel more unique and to stand out. But even though this is what producers want to have a studio like, this is what their studio actually looks like. It's usually just a $100 MIDI keyboard, some speakers, and some software. Um, the main software that producers use is called DAW. It's a digital audio workstation, and this is where the producer builds their sound. So they apply the notes and the samples that they want to use, and all the music is built in this software. And the DAWs are very dependent in plugins, which are extensions to those DAWs. So through the plugins, they can get more tools and more variables to their sound and make it more unique and stand out. So if you're a programmer or you're getting into programming and you also like to produce music, there's a way for you to pursue your own uniqueness without spending hundreds of dollars or thousands of dollars in analog gear, and without knowing anything about electronics to build synthesizers or any kind of experience in instrument manufacturing, which is for you to build your own tools or your own plugins for you to work in your digital audio workstation without spending a buck. So one way to do that is by using JUCE. Um, so what is JUCE? JUCE is an audio application framework. It's made by a company called Raleigh. It's a London-based a music technology company, and JUCE is used very extensively through the industry. It's used by companies like Korg, which makes synthesizers and plugins and software. It's also used for Max for Live, which is a software which enhances the Ableton workstation. It's also used by Raleigh for them to build their own plugins. So a little more about JUCE. The first thing I want to mention is that they have a really strong community. In their website, you can find forums with lots of active users, and they're quite active and they're very helpful. There's also a lot of documentation there, so you'll probably won't get lost if you want to get into it. The next 2 points is that it's open source and it's free, but not quite, because it's open source because you can take a look at the code. It's on GitHub. You can compile it and change it if you really want to, for whatever reason. But they do not accept contributions from outsiders, just from their own team. And it's also free if you're using it for personal purposes, or if you are a small company that's not making a lot of profit. If you're making a lot of profit, you have to buy licenses for your team. Oh, and also you can use it not only for plugins, but you can also build standalone applications for many platforms, including mobile and desktop. So it supports everything. And you can also use it on any platform that you want. So you can develop it in Mac, Linux, or Windows. So I don't have JUCE installed in this machine, or I don't have I don't have a DAW in this machine. So I'll have to use screenshots and videos. I hope that's okay with you all. So I'm going to show you an example of um, how we can build our own application. So we're going to be building a plugin. It's really basic, but I hope you can get more interested in this stuff if you are already into your production. So this is the first screen that you look when you open up JUCE. As you can see, you can build GUI applications or even animations in OpenGL if you want to integrate visuals with your audio. You can also build standalone applications and libraries, but as I've said, I'm going to be focusing more on building a plugin for our workstations. So if you create your application, you're going to be presented with 4 files, 2 that are called plugin processor, 2 CPP files. So you're going to be working with C++, and 2 header files. So these files are called plugin processor and plugin editor. The plugin processor, you can think of it as the backend of your application. So this is where you're going to apply your maths and your changes to your audio, and also any DSP that you want to apply. Meanwhile, plugin editor is the front end of your application. So that's where you're going to build the UI. You're going to add sliders, knobs, dials, and visualizers. There are also 2 tabs under there, which are modules and exporters. So you can choose the modules that JUCE provides us you to, if you want to import something more or remove something that you don't want to use. And of course, exporters, you can choose the architecture that you're going to be building your application for, your locations, and your export options. Another thing that I want to show you all is the main settings that you can use for your application. So JUCE provides you with lots of code that you can make your changes to based on what you want to build. So if you're going to be using MIDI input or MIDI output, and if you're going to be building like an instrument like a synthesizer, or you're going to be building an effect like reverb, delay, or a compressor, and JUCE will give you some code that you can work on. I'm going to be showing you also the basic structure for each of these files right now. So let's take a look into plugin processor first, because I think this is the most important part. The first block that I want to mention is the prepare to play block. This is the block that's going to be executed as soon as you hit play on your DAW. So if you want to make any initializations or declare any variables, this is where you do it. The next block, and I think the most important block, is the process block. So this is where the magic happens. This is where you're going to apply the maths, your DSPs, and you're going to apply the changes to your sound or the MIDI that you are working with. So this function comes with 2 arguments. The first one is called audio buffer. So this is a buffer that comes with the samples that you're going to be working upon. In this case, samples are the most atomic divisions of sound. You can also use samples in other contexts in music, but in this case, it's small chunks of audio. And also, you're incoming the MIDI messages. So if you're working with a MIDI controller or a keyboard or anything like that, the messages are going to be coming through this object. Also, you have the input channels and the output channels. You can think of this, in most cases, is the left and right channel from your input and your output. And so basically what happens is the audio is going to be coming through the input channels. You're going to apply your changes and apply your maths, and it's going to be outputted through the output channels. Um, then we also have the get state information and set state information. I'm not going to be covering that in my example, but this is pretty much where you would deal with data saving. So if you want to save some settings or save some presets, this is where you would have to work upon. So now let's take a look at the plugin editor. So as I said earlier, this is the front end of our application. So this is where you draw the components like dials, knobs, or sliders and whatnot. Right now, of course, it just sets a background color and it displays the hello world text on it. So we're going to be building an effect application. But first, I'm going to show you what happens if you build this and throw it into your DAW. I'm sorry, I do have to use recordings again. So pretty much, if you compile that, I'm going to skip the compiling part because this takes a while, and also because my computer is really, really laggy. So I'm going to skip right into importing it into Ableton, okay? I do not think this is the right video, I'm sorry. Okay, no, this is it, okay. So let's again skip right into importing it into Ableton. Okay, so I built that, I imported it into Ableton. You just copy and paste the VST file, which it created. I forgot to mention, VSTs is what plugins are called most times. So yeah, my computer freezed again. Give it a second. Okay, there we go. We have our base compressor. I loaded it into Ableton. I'm gonna load a sample into an audio channel, which this plugin is gonna be applied, but nothing happens to audio. Oh, also, this is kind of a bummer, but I just found out that my recordings don't have audio because I screwed up when I was recording, so you're gonna have to bear with that. So pretty much this is just the Hello World screen that I showed earlier. It's doing absolutely nothing to our sound whatsoever. Okay? Okay, so I think that if we're gonna build an application for an example here, I don't think there's a better example that I wanted to use rather than a compressor, because it's very widely used and it's really easy to understand, and it also had a little bit of maths in the background that I can explain. Okay. So what the compressor does, if we take a look at this graph, basically we have an input level, and then we set a threshold, and everything that goes above this threshold, and we're talking about volume here, okay? So everything that goes above this volume is going to be divided by a ratio which we apply. So basically, if we apply a ratio of 1, no compression is going to be applied. And if you set it to infinite, it's going to work kind of like a limiter. So what this does, it pretty much makes louder sounds quieter. And you can, with this, you can work easier with audio because it's going to be way more even, and you can mix and match it with other audio with more ease. And it also makes the sound punchier and heavier, which nowadays is really important for music. And it's all because of that guy that I showed earlier, Rick Rubin. With this, you kind of lose dynamics, which gives body and flavor to your sound. But again, you get a punchier and heavier sound, so we kind of want that. Oh, also there are some elements to our to compressors that I'm not going to be dealing with. You usually have attack and release times and the knee of your compressor, but I'm going to be focusing on the threshold and the ratio, and also on output gain. Okay, so let's start by working with our output gain. So the output gain is pretty much just a volume slider. Okay, the first thing I gotta do Again, I had to record the video because if I were live coding, I would probably fuck it up, and I don't want that. So I just declared a variable in my header for the incoming gain. Right now, it's going to be just a static value, which you're going to set to. Let me speed things up a bit. Okay, sure. So I pretty much just declared a variable with a value of 0.015. And then all I have to do is iterate through the samples that are coming into my buffer. So I just access my buffer, get the number of samples, and iterate through each one of them. And then all I have to do is I'm going to get the data that's coming from our channel, and I'm going to replace it with something else. I'm going to be replacing it, in this case, with the current sample that's coming from our buffer. So I'm going to get the sample from the buffer, the channel, and the sample. And I'm going to multiply it by our variable incoming gain. Okay? So let's take a look into what that does. Again, there's no audio. I'm so sorry. So right now, if you take a look at the left bottom corner of the screen, you can see that the input audio and the output audio is very different. So the output audio is being multiplied by the number that we declared. So let's make this functional. We want to control the audio. We don't want to change the code every time that we want to change the volume of our audio. So let's build a simple slider for that. I'm going to be starting with the front end of it. So I'm just going to create a slider. Oh, we're dealing with the plugin editor right now. I'm going to change the size of my screen. Then I'm going to take that slider that I created. I'm going to set it as style. In this case, I'm going to be using a rotary dial, so it's going to look like a knob. Let's speed things up. Okay, let's make things more interesting. Then I set a range for it. It's going to go from 0 up to 1. And the last argument is the step of my knob. And I'm going to also be setting a default value for it. And the next thing you're going to do is make the text of it appear below it. This is the current value of my slider. And I'm also going to just add it to our UI. I'm going to add it and make it visible. And then the last thing I got to do is set the boundaries for it. So I'm just going to use the current bounds of my window because there are no other elements right now. So if I build that and throw it into Ableton, we can see that there's a dial, working dial, but it does nothing to our audio. I forgot to remove the hello world text, but I'm going to do that later. So now that we have the front end of our output gain slider, let's make it functional. So to do that, all we have to do is add a listener to it. So our application is listening to the changes that I'm applying. I added it to the constructor. And then I also have to override the default function for it because we're gonna be making some changes into it. So inside my plugin editor, just change the step right there because it wasn't quite optimal. I also removed the hello world text because I forgot. So the next thing you gotta do is override the default function for the slider value change, which is our listener. So it's gonna be receiving a slider, and all I have to do is check if the slider that the changes are being applied is the one that we want to be using. In this case, there's only one, but we still got to do that. So I'm going to be using the processor object, which is the object that makes the communication between the backend and the front end. And I'm going to be taking the value from that slider and I'm going to apply it into the variable that's in our backend. Okay. So I just add the listener to my slider. And now my variable in the backend is actually receiving the value from my knob. So I just changed my variable in the backend, removed the static value, and now if I load that into Ableton, the slider is going to be working. So take a look at the left bottom corner of the screen. If I change the value, it's going to change the volume of my sound. But there's still a little bit of problem that we have to fix before I move on. So if you take a look, the changes that I make in the louder parts of my slider are not quite as powerful as the changes that I make in the lower values of my linear way. So we gotta use some sort of calculations to make it appear linear. And the way to do that, we have an equation. Just give me a second. Which is this. So in this case, x is the multiplier that we have to apply to our audio, and dB is the number that's coming from our knob. So what happens is dB is equals 20 to 20 multiplied by the log base 10 of x. So I'm not going to be covering how we're gonna solve that, but we have to isolate x. So long story short, math happens, and x is equals 10 to the power of dB divided by 20. Again, x is our multiplier, and dB is the current value of our knob. So to fix that, it's actually quite easy. All we have to do is change how the values work. Okay, so let's go to the backend of our application. I'm going to change the range of our knob. I'm going to go from -70 up to 6 because this looks more like an actual compressor. Then all I got to do is create a new variable, which is going to receive our fixed value. And we apply that equation to the value. So 10 to the power of our incoming gain divided by 20. And all I got to do is use that variable now. So now use your imagination and perceive that the audio is working properly. Wow, this is really fast. But okay, let me slow things down again. There we go. So if you take a look at the left volume visualizer right here in Ozone, you'll see that the changes that I make are looking way more linear, or rather, we're perceiving it more linearly. So the changes I make in the louder values looks the same as the changes that I make in the lower levels. Okay? So now that we have our working output gain, we have to move on to the actual compression of our sound. So let's take a deeper look into how a compressor works again by taking a look at this graph. So pretty much this is the input level through time. And as I've mentioned earlier, we set a threshold. And everything that goes above that threshold is going to be divided by the ratio which we defined by the slider. And this is going to make the sound more even. I'm not going to show you how to create the sliders because we've already done that. So just assume that we already have 2 more sliders, one for our threshold and one for our ratio, and that they're already defined. And let's get right into the DSP part of it. Okay, I'm just going to show the sliders. They're still not working, but just so you can understand what's going on. So the first slider is our original slider. So it's our output gain. The middle slider is our threshold. And the last one is our ratio. It's not working yet. It's just so you get the grasp of what's going to happen. And let's get into the backend and apply the DSP. So we hop into the plugin processor part. We're going to remove our original logic. the first thing I got to do is isolate my current sample because we're going to be using that. Let's speed up that again. Okay, so I've isolated my current sample. Then I also have to isolate the current sign of my current sample because the sample can range from a value from -1 up to +1, and because I also have to use the absolute value of it, so I have to save my sign. So I get the absolute value of my sample. And I also have to fix the threshold slider, just like I did with the output gain slider. I'm just going to apply the same calculations as I did before. So 10 to the power of my incoming threshold divided by 20. You can see I made a typo there, also in the calculation, but I'm probably going to fix that later. All right, at least I hope so. Oh, so how I'm going to apply the compressor is, the compression is rather easy. I'm just going to divide the sample into two parts. The first one is what I call the excess, and it's the values that are above my threshold. So if my current sample is higher than my linear threshold, yeah, I didn't fix the incoming gain mistake, but the code is on GitHub and it was fixed later. So if my current sample has a greater gain than my linear threshold, I'm just going to get the difference between them, or else no compression is going to be applied. And then all I have to do is take that excess, divided it by my incoming ratio, and multiply that by my sign. Okay, so now we have the compressed value of everything that's above my threshold. And the second part of the audio is actually the base, so everything below it. So now all I gotta do is replace the current value of my sample. So I'm gonna take the current value of my sample. I'm gonna remove the excess, the original excess rather, multiply that by our sign. And then we're gonna add the compressed value. So now our audio is compressed, and it's also, I'm gonna multiply that by our output gain. So this is a very, very fast compressor. It doesn't have any kind of attack or release, so it's not quite useful, but just so you can get the idea of how it works. So let's just see the compressor working right now. And I'll load that into an audio channel. So now if I change my threshold, you're going to see that I'm going to lower the threshold, and you can see that the audio spikes are being compressed, and my sound looks more like a block instead of a fish spine. So that means that our compressor is working. And there's no audio again, so use your imagination. Okay, so that's actually all I wanted to cover. I just wanted to show you how you can use your own knowledge, or rather how you can pursue new knowledges for you to enhance your uniqueness, and how to apply some more uniqueness to your sound. So you don't have to be a luthier or an eccentric synth aficionado to pursue your authenticity. You can also build your own tools for you to be more unique. And I hope you do that. I think that it's a powerful tool, and it's something that can be used quite extensively. So create your own plugins, create your own tools, be unique, and break away from the current mindset from the music production. And I think that's it. I hope you all enjoyed it, and you're going to pursue this. So thank you.